In ultrasound imaging, we obtain information from inside the body through the echoes of the sound. But what exactly is sound? In this video, you will get a brief introduction of sound. And in particular, I will tell you about the concepts of frequency, speed of sound, and wavelength. First, I'll give you a brief definition in words of what sound is. One such definition could be that sound is a mechanical disturbance from a state of equilibrium that propagates through an elastic medium. So we have a medium, which could be air or water, and we create a disturbance, and that disturbance propagates through the medium, and we have a sound wave. Well, that's a lot of words, but it's much more useful to see it happening. So we have stimulated a medium in which we follow individual randomly chosen points. And the medium has an elasticity. And now we push by the piston at the left to the medium. So that creates a force to these particles, and these particles push against the neighboring particles, etc., etc. And now we have a wave of high and low pressures moving through the medium. That is exactly what sound is, a pressure wave moving through the medium. The source of sound is characterized mainly by its frequency, the number of vibrations or the number of cycles per second, expressed in hertz. Here we have a medium that is disturbed by a rather low frequency, and this medium is being disturbed by a rather high frequency sound source. We see that the distance between the high pressure regions is smaller if the frequency of the disturbance is higher. So in the low frequency medium, we have a large wavelength. And in the high frequency medium, we have a small wavelength. The frequency of the sound determines the pitch that we hear, if we hear the sound. This is a frequency of 500 hertz. Now we increase the frequency to 1000 hertz or 1 kilohertz. Again we increase it to 5 kilohertz. And now it's increased to 10 kilohertz. And some of you may have stopped hearing this. And nobody will be able to hear frequencies above 20 kilohertz. And that is what we call ultrasound. Ultrasound is sound at frequencies that no human can hear. So sound with frequencies between 20 Hz and 20 kHz is called audible sound. And sound at frequencies exceeding 20 kHz, that's what we call ultrasound. And for medical imaging, using ultrasound, we use the frequencies between 1 MHz and 20 MHz. So now, given the frequency of the disturbance, let's now have a look at the medium. Here we have a medium which is characterized by a low speed of sound. And we have a medium which has a high propagation speed of the sound. And we see that in the low speed of sound medium, we have a small wavelength. In the high speed of sound medium, we have a large wavelength. So, if we look at the various media inside the body, what are the speeds of sound? Well, first of all, we have air, which has a speed of sound of 330 meters per second. And then we have the group of so-called soft tissues, like water or muscle. And these have speeds of sound of about 1.5 kilometers per second, 1500 meters per second. And the highest speed of sound we encounter in bone, which has a sound propagation speed of more than 4 kilometers per second. So we've seen that the speed of sound, the frequency and the wavelength of the sound have a mutual relationship. And that relationship is that the wavelength of the sound is equal to the speed of sound divided by the frequency of the sound. So if you now look at a typical tissue which has a speed of sound of 1500 meters per second, for a frequency of 1 megahertz, we have a wavelength of 1.5 millimeters. And that's the thickness of a match. And if we increase the frequency, we get smaller and smaller wavelengths. And for the maximum frequency of 20 megahertz, the wavelength is only 75 micrometers. And that's the thickness of a human hair. So if we go back to the question, what is sound? Sound is a pressure wave with a frequency larger than 20 hertz. And ultrasound has frequencies larger than 20 kilohertz that nobody can hear. And for ultrasound imaging, we use frequencies above 1 megahertz. Sound propagates in a typical tissue at the speed of 1500 meters per second. And it has a wavelength of 1.5 millimeter or smaller. So this was a brief introduction into sound. In medical imaging, we use ultrasound. And we use the various properties of the tissues in the body to obtain information from inside the human body.